Hello, and in this video we're going to start section 4.1 with an introduction of what polynomial and power functions are. In this series of videos we're going to have three that are going to work in section 4.1. This one is just going to introduce what a polynomial function is, some vocabulary for a polynomial function, and how it's related to a power function, and a little bit about end behavior of those types of functions. So let's start with what is a polynomial function? Well, a polynomial function is a function that has variables to integer powers, and they have to be positive integer powers. So some examples of polynomial functions are just a constant function, 3. So that's an example of a polynomial function. Another polynomial function is your line function, 5x minus 2. It's a linear function. This is a constant. Another polynomial function is a quadratic. It's a quadratic. So any function that has a constant value in front of a variable, or a constant value, and an x to a power of a value greater than 0 would be considered a polynomial function. So in general, a polynomial function has, for its general term, f of x equals some constant times x to a power plus the next constant, and x to a power less than that. We can go 1 less, and we can go 2 less. Another constant times x to the power down thing, and then we can go all the way down to, so that we can say a sub 2 x squared, a sub 1 x, and a, which is the constant. Here's our constant. So we just count our way down from the highest power down to a power of x to the 0. There's actually an x to the 0 right here. You don't see it by the constant, because anything to the 0 power is 1. But a polynomial function is in this form: some value in front of x to a power that's greater than or equal to 0. The power has to be greater than or equal to 0, and it has to be a whole number counting power, and has to be a whole number. All right, so that's what a polynomial function is in general. Now, each of these values here, each of these values is called a term in the polynomial function. Each of these is called a term. So in this, for example, in this quadratic function right here, 5x squared is a term, negative 2x is a term, 1 is a term. So each of those are called a term. The leading term is the power, or the term is the term with the largest exponent. still learning this process. Largest exponent. It's usually written in the front of the polynomial function. So our example would be f of x equals 16x squared minus 5x to the third plus 1. Our leading term, which is not written in order here, if we want to write this in order, we'd write it negative 5x cubed plus 16x squared plus 1. Our leading term would be 5x cubed. This is our lead term. And also the leading coefficient is the negative 5. So leading coefficient is the number in front of that variable. Leading coefficient equals negative 5 in this case. It's the one in front of that. Okay, so we went over terms. The degree, we went over a leading term and leading coefficient. The degree of the polynomial is the highest exponent. The degree of polynomial equals the highest exponent, largest. So in this case, our degree of this polynomial is a degree of 3. Here's our degree right here. So a degree of 3. In this example. So we have a lead term, we have a leading coefficient, we have the degree of the polynomial. Now each term also has a degree. This term here has a degree of 2, this term here has a degree of 0 because it doesn't have a thing. This has a degree equal to 0. So this one has a degree of equal to 2. So the degree of the polynomial is the largest degree. Now, after we look at polynomials, we want to look at power functions. Power functions are single-term monomial functions. Are single-term monomial functions that have a power that equals a integer that's the same as the polynomial function. It's just basically the lead term. We think of the power function as one of the lead terms. Each polynomial function has several power functions involved in it, but the power function is just a coefficient x to a power of n, where n is an integer that's greater than or equal to 0. All right, so some power functions that we have here, if we just look at the first power functions we have, starting with, let's start with 0. So our first power function is a constant like 1. Our second power function is an x. Our third power function is an x squared. We'll put a 3 in front of it. Our fourth power function equals negative 5x cubed. So anything like this can be a power function. These are examples of power functions. This is a constant function. This is a linear. This is quadratic. This is a cubic. So power functions have one term in them. They have a coefficient and they have a power of x. And that's what a power function is. It's just a part of the polynomial function. Polynomial functions are made up of several power functions, each added to each other in a polynomial function format. Now we're going to look at end behaviors of these types of functions. So an end behavior is what happens to the graph of a polynomial function when we look at the right and left hand ends. So end behavior is what happens to graph as it travels left and right to negative infinity or positive infinity. So what we're going to be doing is we're going to be looking at this statement here. We're going to say what happens to f of x as x goes to infinity or negative infinity. We're going to say what happens to f of x, or as x goes to positive infinity, what happens to f of x. So each time we're going to do this, we're going to be looking at the lead coefficient of the power function. We're looking at the lead term of the power function, or of the polynomial function. We're looking at the lead term because that's going to tell us, it's going to match up with the power function. So what we're saying is, if we look at power functions, we can predict what happens to polynomial functions. So if we have f of x equals positive x squared, we're going to have something that looks like this. So that means that that's going to take, as x goes to infinity, we're going to go up here. So f of x goes to infinity. As x goes to negative infinity, that means we go left here. We're going this way now. We still are going up. So we'd say f of x goes to infinity there also. If we look at negative x squared though, f of x equals negative x squared, that's going to look like this, and we're going to change our end behavior. So as x goes to negative infinity, f of x goes to negative infinity, and as x goes to infinity, f of x goes to negative infinity also. So both of these go down as we go left, and this happens on any even power. So this happens on even power functions. Even power functions have this rule. So if it's x to the 4th power, it's going to follow the same thing. If it's x to the 6th power, it's going to follow the same thing. If our lead term of the polynomial function is an even power, it's going to follow the same thing.